Okay, implicit differentiation, find dy dx. So take the derivative of both sides of this guy with respect to y. So that's secant squared 4x plus y. Chain rule, leave input function alone, multiplied by derivative of input function, 4 plus dy dx, and that's equal to 4. Okay, so now solve for dy dx. Well, I'm going to divide both sides by secant squared. So secant squared 4x plus y, secant squared 4x plus y. And of course, dividing by secant squared is the same thing as multiplying by cosine squared. So we might as well change it to cosine. That gives me 4 plus dy dx equals 4 cosine squared 4x plus y. And then I'm going to subtract 4 from both sides, and I get that. Okay, so this, for me, this would be okay for an answer. This showed up in your homework or something similar, and they really wanted to simplify. So I'd be okay with this. If this were a test, I'd be okay with this. But there's something else we can do with that. So I just wanted to show you this little trick of how we can simplify this guy. First of all, I can write this, if you remember from trig class, I could write this as a single trigonometric expression. If you realize you can factor a -4 out, that makes the cosine squared term negative, and this would be positive. So I'll just rearrange them so you can see your Pythagorean identity there. So 1 minus cosine squared is, of course, the sine squared. So that's a better looking answer already. However, we can do even better than this. So that'd be a good answer. But I wanted to show you how they got the answer from the that was given in the answer key. So if we drew a picture, and this is something that's more common really in Calc 2, but if you drew a picture of this original scenario, here is the given equation. Let me just scroll up. This guy, so the tangent of some input is 4x over 1. So that input, let's say we gave him a name, I'll call him theta. So if that's theta, then the tangent would be opposite over adjacent, made that a fraction. And of course this would be this squared plus this squared is the hypotenuse squared, right? A squared plus b squared equals c squared. So if I solved for c, it'd be the square root of 4x squared plus 1 squared, or 16x squared plus 1. Okay? And that's how they're reducing their answer. If I know that the tangent of 4x plus y is this, then that means I know what the sine of 4x plus y is. Call this 4x plus y is theta. So the sine of 4x plus y is opposite over hypotenuse, which is 4x, over the square root of 16x squared plus 1. Okay, so that's just a relationship we can build based on that, what was given. So if I plug that in to where I am now, then I know what the sine of 4x plus y is. The sine of 4x plus y, and its sine squared I have, is 4x over the square root of 16x squared plus 1. Now I can square everything. 16x squared, the square root goes away, 16x squared plus 1 times this -4. So I don't know. That could be -64x squared over 16x squared plus 1. So that is a good answer. It gets it to an algebraic form. But this, for me, is also okay. And even this would be okay. Those are all the same thing for this problem.